Hi students, welcome to Light, Reflection and Refraction Lecture 2. So myself Srilata, your physics teacher on Teach Tigers platform. So let's have a recap of what we have learned in the first lecture. So in the first lecture we discussed about laws of reflection and also what is a concave mirror and a convex mirror, and also the general terms that are related to spherical mirrors. Hope you have watched the lecture 1 so that you are very much familiar with these terms related to spherical mirrors. Okay, so if you have viewed the first lecture, it would be very easy for you to understand the second lecture. So let's proceed and see what we are learning today. So today I would be discussing about normals of the spherical mirror, how to find the focal point of spherical mirrors, and also ray tracing for spherical mirrors. So let us start with the first topic today, so that is normal of spherical mirrors. You already know how to draw the normal for a plane mirror. So just let's see how you would draw the normal for a plane mirror. So this is your plane mirror, right? So on the plane mirror, how do you draw the normal? If suppose there is an incident ray like this, okay, so this becomes the point of incidence. So where do we draw the normal? Normal is always perpendicular to the reflecting surface and passing through the normal, right? So this is passing through the point of incidence and perpendicular to the reflecting surface. This is the normal, right? So now you can easily calculate the angle of incidence, and we know that angle of reflection is equal to angle of incidence, and you are easily constructing the reflected ray from the angle of incidence. So this is the procedure, right? So let us try to apply the same concept to the spherical mirror and see. So if you see here, there is a convex mirror given. If you see, this is a convex mirror and there is a ray of light which is falling on the mirror. So if this is the ray of light, so this becomes the point of incidence. So what did we do here? At the point of incidence, perpendicular to the reflecting surface, we have drawn the normal. So let us try to draw here. If you see here, this is the point of incidence and you should draw perpendicular to the reflecting surface. But here if you see, the reflecting surface is curved. Is it? For a straight line, you can draw perpendicular easily. But for a curved line, how do we draw a perpendicular? You might have seen in circles. Is it? You might have seen and learnt in circles that for circles you can draw a tangent to any point, right? So you can draw a tangent to any point, and perpendicular to the tangent you can draw, and it is observed that the perpendicular to the tangent always passes through the center of curvature of the circle, right? So let us try to apply this. So at the point of incidence, what am I doing? I am just drawing a tangent. So this line is a tangent, right? Now perpendicular to the tangent, I will draw the normal. Okay, so this is the tangent. Now perpendicular to the tangent, you can draw the normal. So now this is the procedure to draw normal, okay, for a curved mirror, for any curved mirror, not even convex. For concave also we can use the same concept. So now you can easily calculate the angle of incidence. If the angle of incidence, you know, on the other side of the normal, making the same angle, you can easily construct the reflected ray. Is it? So it is little bit typical but very easy once you understand. See, you can just take any ray. Now you can take any ray. This is the point of incidence. At the point of incidence, what we have to do? Just draw a tangent, right? Draw a tangent and perpendicular to the tangent, you draw a perpendicular to the tangent, okay, and find the angle of incidence. If you know the angle of incidence, you will get the reflected ray easily, because angle of incidence is equal to angle of reflection. Okay, so this is how we draw normal to the spherical mirrors. Let us try to apply this procedure to the concave mirror. You can see here, there is a concave mirror, right? and there is a parallel ray which is incident on the concave mirror. So now this becomes the point of incidence. So what do? We have to draw a tangent. And we'll draw the normal like perpendicular to the tangent, right? And whenever a normal is drawn, it is just like drawing a tangent to the circle, a part of the circle. Curve is nothing but part of a circle. So there is a tangent at that point and you are drawing perpendicular to the tangent. So you know that the tangent passes through the center of curvature. Even here also it is observed that the normal is always passing through the center of curvature. Now if you see, there is another ray. For this ray also, if you try to draw the normal, it is observed that the normal is always passing through the center of curvature. So now we know the fact. What is the fact? That normal for a concave mirror, at any point you draw on the surface of the concave mirror, it is always passing through the center of curvature. So when you know this fact, so your ray diagram drawing has become much simpler. How? Because we can avoid drawing the tangent, right? So you need not draw the tangent. Why? Because on any surface you want a tangent, you want a normal. What do? Directly you can just draw a normal passing through the center of curvature. We know all the normals will pass through the center of curvature for a concave mirror, right? And it is like, if you draw many normals, it is observed that all the normals are converging at the center of curvature. Okay, so that is how it is concluded that you can see all the normals converge at center of curvature. Okay, at any point also you draw, you will get all the normals, they are converging at the center of curvature. So that is how we made this conclusion that all normals of a concave mirror converge at center of curvature C. Okay, if this is for concave mirror, what about convex mirror? Let us see. Okay, so now you can see there is a convex mirror, so there is a light incident on it. So when the light is incident on it, now again this becomes a point of incidence. So what do? We draw the tangent, right? We draw the tangent, and perpendicular to the tangent, what is it? The normal is being drawn, and it is observed even when you extend this normal line backward, it is observed again it is passing through the center of curvature. Is it? It is again the same thing. So tangent and perpendicular to the tangent. So for a circular surface or a curved surface, when you draw perpendicular to a tangent, it always passes through center of curvature. So the same thing is happening. So all the lines, again if you draw normal at any other point, it is again observed that it is passing through center of curvature. Now you observe all the normals. Observe all the normals here. See here, there is one normal, you can see it is like this, and there is one more normal here, it is like this. So how does it appear to you? It is as if they are emerging from point C. So that we explain it as the normals appear to diverge from center of curvature. So you can see here, normals of a convex mirror appear to diverge from center of curvature. Now we know two facts. What are they? So the normals of a concave mirror, they converge at center of curvature. You draw normal at any point on the circumference of the spherical mirror, all the normals converge in a concave mirror, and all the normals appear to diverge in a convex mirror. Very clear, right? Easy. Next, let us see. There is a small illustration here. Find the normal at the given incident ray. See, there is an incident ray. He is asking to find the normal. So find the normal line. We have to draw the normal line. So again the same procedure. So this is the point of incidence. You know, now you need not draw the tangent. So we have skipped now drawing the tangent. It has become easy because we know normal will pass through center of curvature. Is it? So this is a convex. This is a convex mirror. So we know normal just passes through center of curvature. So normal is a line which joins the point of incidence and the center of curvature. Now you know the normal. This is a normal line. Now you can easily measure the angle of incidence. You can easily measure the angle of reflection also, right? So this is a normal for this ray which is being incident on the convex. So now for any ray you can easily draw the normal now. Next, let us try to understand the focus of a spherical mirror. How to obtain focal point of a spherical mirror. Maybe it is a concave mirror or a convex mirror. So remember, to obtain a focal point, so always parallel rays have to be incident on the spherical mirrors. So from where do we get parallel rays? That will be our next question, right? So I am telling, for obtaining the focal point, what you have to do? Always parallel rays have to be incident. So from where do we get the parallel rays? So parallel rays are obtained from an object which is at infinity. So for example, consider sun. Like sun is at an infinite distance from us, is it? So what type of rays do we receive from the sun? So they are always parallel rays, right? So these are parallel rays, like for any object which is at infinity. So infinity need not be as longer distance as the sun. Infinity can be like the other end of the table for a small mirror, is it? It depends. Infinity depends and changes depending on the size of the mirror. Okay, so infinity, from an object which is at infinity, what type of rays are we getting? We are always getting parallel rays, right? When parallel rays are incident on a mirror, so here I will just draw a concave mirror. Let us try to find the focal point of a concave mirror. So this is a concave mirror, this is pole, focus and the center of curvature. So I am just incidenting parallel rays. Okay, so parallel rays, when you draw the parallel rays, so you know the normal line, is it? So how do you get the reflected rays? You draw the normal line. This is the normal line which is passing through the center of curvature. Now you can measure the angle of incidence, and when angle of reflection is drawn, it is observed that both the reflected rays are passing through a point, and this point is called as focus. Okay, so this is called focus because all the parallel lines which are incident on the concave mirror, they are all focusing at a single point. You can see all the reflected rays, they are meeting at this point, focusing at this point, and this point is named as focus. And that's why this concave mirror, it is also called as converging mirror. Converging mirror, that means where the reflected rays, the rays are meeting. Converging means meeting. Okay, you can see here. So when parallel rays are incident, how are these parallel rays? These rays are parallel to the principal axis. When parallel rays are incident, so the reflected rays, they converge at a point which is called as focus or focal point. And here you can see concave mirror is also called as converging mirror because it is like focusing or meeting all the reflected rays at a single point. Okay, next you can see here the picture of a concave mirror where you can see there are many rays which are incident on it, parallel rays. These are all parallel rays which are incident on it, and you can see they are reflecting, and all the reflected rays, you can see they meet at this point which is called as focal point or focus. Very interesting, right? All rays, they just converge at this point. So that's why this mirror is called converging mirror, right? Next, let us see the focus of a convex mirror. So if you see, this is a convex mirror. Okay, and this is the pole, and this is the center of curvature. This is the focus. Now I want to incident parallel rays. Why are we incidenting only parallel rays? I said only when parallel rays are incident we can obtain the focal point. So parallel rays are incident. When parallel rays are incident, after that we know we have to draw the normal. Is it? So how is the normal? Normal will always, its line passing through the center of curvature. So it is a line through center of curvature to the point of incidence. So this is the normal. When you know the normal, you will know the angle of incidence. Here also angle of incidence. Then what will be the angle of reflection? So this is how you will get the angle of reflection, because angle I is equal to angle R. So now you just observe the reflected rays and just try to, you see that the reflected rays doesn't meet. So I'll extend this reflected rays backward like this. So what did you observe? So the reflected rays are meeting at a point. So that point is called as focus. Okay. So here the reflected rays, if you see, they are actually diverging. So what is a convex mirror doing? The convex mirror is diverging the reflected rays. Therefore, the convex mirror is called as diverging mirror. And where are the reflected rays meeting? The reflected rays, they appear to diverge from focus. They appear to emerge from focus. So that's why this is called as a diverging mirror. So very important, concave mirror is called converging mirror and convex mirror is called diverging mirror. Okay, next let's see this picture of the convex mirror. So here also you can see many parallel rays are incident and you can see all the reflected rays. These are all the reflected rays which are diverging. Is it? They are all diverging, and if you extend these reflected rays, they appear to meet here. So they all appear to diverge from focus. This is how the convex mirror got its name as diverging mirror. So this is all about focus of spherical mirrors. So just have a look at one of the illustration. Here parallel rays of light are reflected by a concave mirror to a point called the. So here parallel rays of light are reflected by which mirror? By a concave mirror to a point called the. So when parallel rays are incident on a concave mirror, they are reflected. And where do they meet? So they meet at center of curvature, pole, focus, point of incidence. Which is the right one? Just now we have discussed that they all converge at the focus. So option C is your right answer. Hope it is very clear to you. Let's proceed with the next topic on ray tracing for spherical mirrors. So we know how we were drawing the normal for a spherical mirrors. How are we drawing the normal? So we are identifying the point of incidence. At the point of incidence we used to draw a tangent, and perpendicular to the tangent we were drawing the normal, and slowly now we understood that normal passes through the center of curvature and we made it easy by skipping drawing the tangent. Now every time, like you know, many rays are incident on the mirror, is it? So every time drawing the incident ray, again drawing the normal and drawing the reflected ray. See, so many lines on the curved mirror, so it becomes very complicated for us to understand, is it? Now we don't want even to draw the normal, even without drawing, how to just construct the reflected ray. So let's see, that is all about ray tracing for spherical mirrors. How is this done? Like some sample rays are being taken and their behavior was studied. Okay, so their behavior was studied and these rays are made the representative rays, so that drawing the ray diagrams has become easy. So where we just show an incident ray and a reflected ray, there is no normal, there is no tangent. Okay, so the work is made very simple and clear. With this ray tracing. Okay, just let us see what is this. So I told you there are representative rays which are being picked and their behavior is studied. So there are 4 such rays that are being taken. So based on that, like there are 4 ray rules which are being formed. So let us see all the 4 ray rules. So if you see the first ray rule, here there is a concave mirror and there is a convex mirror. So you know this is the principal axis, so pole, center of curvature, again this is the focus. Okay, so the first rule states that when a ray is incident parallel to the principal axis, okay, if a ray is incident parallel to the principal axis, it reflects and passes through the focus. Okay, if you remember this, again you need not draw the tangent, not the normal, very easy and interesting, right? So the same thing we'll try to draw for convex also. Okay, so for a convex mirror, if you see, this is the pole, this becomes the center of curvature, this is the focus. Now if a ray is incident, so what does the first rule say? If a ray is incident parallel to the curved surface or the curved mirror, what happens? It reflects and passes through the focus. But here if you see, this is a virtual focus, the ray cannot pass through the focus, then from where it does go? So it just reflects back, and this is a diverging mirror and it appears as if it is coming from the focus. Very simple, is it? So what is the first rule? You can see a ray parallel to the principal axis after reflection will pass through the principal focus. Okay, which is parallel, after reflection it passes through the focus in case of a concave mirror and appear to diverge. Okay, it appears to diverge in the case of convex mirror. So this is the first ray rule. So let's proceed with the second ray rule. So second ray rule is very easy, just the converse of the rule 1. So what does it mean? Again we know here this is the pole, center of curvature, focus. So the same way here, this is pole, center of curvature and the focus, right? Here if you see, just the converse I said. So what does it mean? In the first rule, when you are incidenting a parallel ray, the light ray was reflecting and passing through the focus. Just the opposite, applying the principle of reversibility which we have learnt in the first lecture, if you remember. So here when light is passing incident and it is passing through the focus, it reflects back and travels parallel to the principal axis. Very easy and simple, right? So the same way here if you see, since this is a diverging mirror, we can't pass any ray through the focus, it is a virtual focus. So we will just incident a ray which is in line with focus. Okay, so after reflection it travels parallel to the principal axis, right? So this is the rule number 2. You can see a ray passing through the principal focus of a concave mirror or a ray which is directed towards the principal focus of a convex mirror, after reflection it will emerge parallel to the principal axis, right? Next let us see the rule 3. If you see this rule 3, this is the rule 3. So what is the rule 3? So this is pole, center of curvature, focus. The same way this is pole, focus and center of curvature. This is the center of curvature. Now if you see here, if a ray is incident passing through the center of curvature, okay, a ray is incident passing through the center of curvature, it just retraces its path. That means the reflected ray just reverses its direction and just follows the same path. Okay, so this is ray rule 3. So the same way let us try for the convex mirror. So if a ray is passing through the center of curvature, here again it is a virtual center of curvature, that means this ray is incident in line with center of curvature, then after reflection it just retraces its path. Okay, it just reverses its direction but follows the same path. So here a ray passing through center of curvature of a concave mirror is directed in the direction of center of curvature of a convex mirror after reflection. So it is reflected back along the same path. So this is about ray rule 3. Very easy, right? Next, let us see the fourth rule. So what is the fourth rule? Again, we know this is pole, focus, the center of curvature. So here also this is pole, focus and the center of curvature. If a ray is incident obliquely, what do you mean by the word obliquely? Obliquely is nothing but making an angle with the principal axis. So if a ray is incident at the pole making an angle with the principal axis, it reflects back making the same angle with the principal axis. So the same rule again applies for the convex mirror also. If you see here, if a ray is incident making an angle with the principal axis, it reflects back making the same angle with the principal axis. You can see here. So this is the fourth rule. You can see, very easy. So these 4 rules. Now here in all the 4 rules, if you see, if you just learn this rays, okay, this behavior was studied and it is given to us. When you are using them, we have just avoided drawing the tangent, is it? Drawing the tangent and even drawing the normal. So let us see that. So all the 4 ray rules are being summarized and is being shown here. You can see a ray parallel will pass through the focus. Parallel, it is in line passing through the focus. The second rule, it is converse of the first rule. What is it? A ray which is passing through the focus, after reflection it travels parallel to the principal axis. Here also you can see parallel and it is incident along the focus. After reflection it travels parallel to the principal axis. Here you can see a ray which is passing to center of curvature, after reflection it retraces its path. The same way here. Here you can see a ray which is incident making an angle with the principal axis. It bounces back making the same angle in both the cases. So this is all about the ray rules. Here there is a very simple illustration for you based on the ray rules. What is the question? Complete the ray diagram. Okay, so what is this mirror? First identify the mirror given to you. What is a mirror here? So here you can see it is a convex mirror. It is a convex mirror. There is a light, you can see it is incident parallel. So which rule is this? So when a ray is incident parallel, which rule is this? This is rule number 1. Yes or no? This is rule number 1. When a ray is incident parallel, so what happens? This is the point of incidence. It reflects back, is it? It reflects back as if it is passing through the focus, or as if it is diverging from focus. Okay, so it reflects back in a line with focus like this. So since it is a convex mirror, now what we are doing? We did not draw the tangent, we did not draw the normal. Now just the ray diagram. If you see, it is just there is an incident ray and there is a reflected ray. Very simple and clear, right? So this is all about lecture 2 on light. So I'll be back with another video on application of this concept. See you all.